Hello everyone, welcome to this video. In our previous video, we learned about Euclid's division lemma. In this video, we will study the fundamental theorem of arithmetic. Can you group these numbers into composite numbers and prime numbers? Pause the video to group them and then match your answer. Hope your answer is correct. Now if we choose any one of these numbers, suppose 102 and proceed, then can you write 102 as the product of its prime factors? (102) can be written as the product of its prime factors, that is 2, 3 and 17. Well done! Now if we observe it carefully, then we will notice that we can multiply prime numbers to get a natural number. Let us understand this in detail. If we take a group of prime numbers and multiply some or all these numbers any number of times, we will get a positive integer in each case. Therefore, we can say that any positive integer can be written as the product of powers of prime numbers. Can you think of any composite number which cannot be written as the product of powers of prime numbers? Let us try to answer this. Let us factorize a positive integer, say 1,08,108. Can you show how to factorize this number? Perfect! We can find its factors with the help of a factor tree. In this way, we can factorize 1,08,108 as a product of prime numbers, which is in the form of powers of prime numbers. What do you understand from this? From this we understand that every composite number can be written as the product of the powers of prime numbers. And if the sequence of prime numbers is not taken into consideration, then composite number can be written in the same method as the powers of the prime number. You can check this theorem by trying out some more examples of similar kind. This is a true statement which plays an important role in the study of integers. This is the reason why this statement is called the fundamental theorem of arithmetic. It was introduced by Sir Carl Friedrich Gauss. According to him, each composite number can be expressed or factorized as a product of prime numbers, and this factorization is unique irrespective of the order of the prime factors. In this video, we have studied the fundamental theorem of arithmetic. In the next video, we will see few of its applications. Hello everyone, welcome to this video. In the previous video, we learnt about the fundamental theorem of arithmetic. In this video, we will see few of its applications. Can you write 12 and 45 as the product of their prime factors? Pause the video to factorize it and try it yourself. Well done! If you have written the same prime factors, then your answer is correct. But if you have written some other factors, then your answer is wrong because the uniqueness of the fundamental theorem of arithmetic determines that each composite number can be expressed as a product of prime numbers, and this factorization is unique except for the order of the factors. Let us now discuss the factors of 12 and 45. We can see that the common factors of both the numbers is 3. What do you understand by this? We have learned in the previous video that the product of the common prime factors of two positive numbers is called the highest common factor, HCF. Also, if we observe carefully, like HCF, we can also find the least common multiple, LCM, which is the product of the highest powers of the prime factors of both the numbers, that is the LCM of 12 and 45 is 180. What more do you notice here? Can you guess what will we get if we multiply HCF and LCM of 12 and 45? Perfect. We will get 540. On observing carefully, we find that it is equal to the product of 12 and 45. On the basis of which, it can be concluded that the product of any two positive integers, a and b, and the product of their HCF and LCM are the same. Now the question arises whether the same rule is applicable if we take more than two numbers. Let's examine this with the help of two examples. We shall take the HCF and LCM of 3 numbers in the first case and 4 numbers in the second case. On solving, you will find that the product of numbers and the product of their HCF and LCM are not equal. Thus, we can say that this statement is not valid for more than two positive integers. You can also test this by taking any group of numbers yourself. In this video, we learnt about the relationship between two positive integers and their HCF and LCM with the help of the fundamental theorem of arithmetic. In the next video, we will see an example based on this. Hello everyone, welcome to this video. In the previous video, we learned about the fundamental theorem of arithmetic. In this video, we will see some interesting examples based on it. check whether there is any value of n for which 7 raised to the power n ends with digit 0? We know that if a number ends with 0, it will be divisible by 10. So, we can say that if the number 7 raised to the power n ends with the digit 0, then it will be divisible by 10. This means that 7 raised to n should have 2 and 5 among its prime factors. Is it possible? No, this is not possible because if we look at the prime factorization of 7, we get only 1 and 7. So, the uniqueness of the fundamental theorem of arithmetic guarantees that there are no other primes, that is, 2 and 5, in the factorization of 7 raised to the power n. Based on this, we can say that there is no natural number which has the power of 7 raised to n whose last digit is 0. Let us look at another example. The HCF and LCM of two numbers A and B are 51 and 4335 respectively. If A is equal to 255, find the value of B. Can you guess how the value of B can be found? We learned in our previous video that the product of two positive integers and the product of their HCF and LCM is always the same. Now, if we substitute these values given in the question in this formula and solve them, hence, the value of B will be 867. In this video, we have seen an example based on the fundamental theorem of arithmetic and observed the relationship between two positive integers and their HCF and LCM. Hopefully, you have understood the fundamental theorem of arithmetic and its use.